All right, so let me just first start with how to install Annotator. And I'm gonna even download a new version of Fiji if it doesn't take too much time. Yeah, no, that's not too bad. So yeah, don't hesitate to interrupt if you have any question. That's great. That's better than me always talking. And so yeah, we can use the Slack channel, we can use the chat. That's great ideas. You're great guys. So all right, now it's downloaded, so I'm gonna extract it. And so Annotator is available as a plugin in Fiji, so that's why I'm opening Fiji. So when you open it, you might be familiar with that. I guess you already have installed plugins with Fiji, but maybe not yet. So what you do is you go to Help and Update. And if you can do it all right now, it's great because then you're going to use the plugin, so you need to install it. So if you go to Help and Update, then you have a new window that pops up where you have a list of plugins. So you have a list of plugins that is already embedded into Fiji. Annotator is not already embedded into Fiji, so you need to add the URL that is associated with Annotator. But you're going to see it's very easy to do. So as it's the first time I do it, it takes sometimes. When you do it regularly, it doesn't take that much time. The good thing is that if there's a new version of any plugin you use, included Annotator, then when you do that, Help Update, you can directly update your plugin. So to add Annotator, you need to, so let me, I forgot to tell you, you need to hit Manage Update Sites in this new window. And then you have the list of plugins. So you have the plugins that are already installed. You have a list of plugins that are embedded in Fiji and you can install. Now, as you can see, Annotator is not there. So you need to add a new URL. To do that, you hit Add Update Site. So there's the name doesn't matter. You can change it, but that doesn't matter. What is really important is to type the right URL. As you can see, they all start in the same way, and Annotator also starts with the same way. So you can just type in HTTPS, sorry, sites image.net, all right? So like the other ones, and then you just type in Annotator, small letters. And when you are done like this, you can just close it. So you hit close. And you can see there's a new file is going to be installed. So it's called new because I didn't change the name. But it's going to look for the new URL and it's going to find Annotator. And as you can see now, you have plugin/2d annotator.jar that appears here in this window. So I just want to make sure that everybody followed here because that's important. Anybody is fine? Is there any questions so far? Any problem? Seems to be right. So if you followed that, then you just need to hit Apply Changes. And you updated all the plugins. So now to get Annotator, you need to restart it. So I'm going to close Fiji, restart it. And now, if you go to plugins, if you go at the bottom, so you need to hit the arrow is going down. Now you can see you have Annotator. Does everyone manage to install Annotator, or is there any problem? it's time now to check for it, because then we're going to use it. So I just want to make sure that everyone has an annotator. So if you go, you have 3 folders: images, regions, and segmentation. So we're gonna open Annotator. So if you go to plugins and you hit Annotator, then it's asking you which image you want to open. So if you go in the images folder, we're gonna select the first image. And that's what it looks like. All right. So let me, so when it opens, it's opened already zoomed in. So you can zoom in, zoom out with your mouse. So if you scroll with your mouse, you can zoom in or zoom out. You can also use your keyboard, minus or plus, and you see it's working. So one thing that is important, sometimes if you try to zoom in or zoom out and it's not working, it's probably because it doesn't know that you're in the image. So you need to just click with your mouse in the image, and then it's going to work. So you can zoom in, zoom out. You can really zoom in, and then you can also navigate in the image. So by using the arrows of your keyboard, right, left, top, and bottom. So you can navigate like this. You can also, as in Fiji, as usual, you can hit the space bar and then use your mouse and just pan your image like this. All right. So let me just show you briefly the different the different panels of the plugin. So on the left, you have the annotation panel, so objects and widgets. We'll see what it's useful for. On the right, you have one panel for the visualization tool and one for analysis. And on top, you have the 2 different modes. So we're going to start with the annotation mode, so object and region annotation mode. And then when your objects are defined, you can also associate markers. So you can, if you hit marker annotation, you're in the second mode, and you can see you also have the same kind of presentation. You have the visualization tool on the right with analysis at the bottom right, and you also have tools to do marker annotation. But of course, before doing marker annotation, you need to define objects. So we're going to go back to objects, and that's what we're going to start with. So first of all, let me show you the visualization tool. It's very simple. So you have either you look at all channels together, or you can look at a combination of channels. So here, for example, we have DAPI in channel 1, and you can look at cytokeratin at the same time, for example, and you can add CD8 here. This is CD4, I think, or you can remove one, add others. It's fairly simple. Or you can look at each channel independently in black and white. So for example, if you want to annotate nuclei, that's what you want to do, because in blue, we don't see well. We don't see contrast, we don't see really well, but in black and white, it's much easier to do your annotation.
Can I ask a question real quick?
Sure.
Is there a limit to the number of channels?
Yes, there's a limit to the number of channels. So for now, the way I design it is that 7 channels is the maximum, because that's the maximum of channels you can visualize at the same time with Fiji, and that's with ImageJ actually. So, and that's a limitation of ImageJ. And as I'm just working with multiplexed images, we never have more than 7 channels. Of course, you can have more than 7 channels with different technologies. And in that case, that won't work. But it's very much possible that there will be a future version where you can have more than 7 channels. But in that case, if it's still in Fiji, I will have to find a solution because you can only, so again, you can only look at 7 channels. So that would be combination of 7 channels at most at the same time. Very, very good point, Mike. So you can look at each channel independently. And you can look at them all at once. So as in any image you can use in Fiji, you can change the range of intensity that is observed. And so the easiest way to do it is to go to image, adjust, and brightness contrast. And you can just select the channel you want to change the range of intensity that is observed, like this. And for example, so this is DAPI, and then you can decrease the maximum of intensity that is observed, just to adjust in a better way so you can better visualize your image. And you can do it for all of them, of course. And maybe the cytokeratin can be also adjusted. And if you go back, of course, it hasn't changed. So you still have the same parameterization for your range of intensity that is observed. So that's it for the visualization. Is there any question about it? It's very, fairly straightforward, and it's actually just using the tools that are available in Fiji, but just embedded into the plugin, so it's easier to navigate between channels or look at a couple of channels. For example, here, if you want to annotate your nuclei, of course, the best way to do it is to look at your DAPI channel in black and white. But sometimes it can help to also look at different channels at the same time. So especially if you look at the epithelium. So something I didn't mention before, but as you can see, these images are pretty challenging. You have a lot of nuclei, but nuclei are very cluttered, and it's a wide field microscope. So sometimes you don't know. So in this region, for example, let me just zoom out a little bit. Like in here, it's very difficult to know where your nuclei are. It's very packed. So sometimes it's easier to look at cytokeratin at the same time, where you have cytoplasm between the nuclei, and it helps you to differentiate the different nuclei. I'm just going to show you. So I don't know if you can see. So I tried. So that's so I saw it in the presentation of the workshop, but it's better to have a drawing tablet like this. I don't know if you can see it. Something you can use a pen directly on it. It's fairly cheap. It's just about $60 here, and it saves you a lot of time when you need to annotate images. So I'm going to use it to show you how you can annotate. So the first part is the object annotation. So that's this panel, and as you can see, you have different actions you can do. So let me just select the DAPI, zoom in, maybe in a region that not that challenging. Let's try here. So you can zoom in, zoom out to be comfortable with your annotation, and then so if you have add object in your object annotation panel, you can just start annotating your nuclei. So I'm going to zoom in a little bit. And so with a drawing tablet, it's much faster than with a mouse. So as you can see, it's just a region of interest as defined in Fiji. So if you don't go up to the end, it's gonna just directly link the first point and the last point. And the other thing is that as one pixel cannot belong to two objects, if you go on top of a previous object like this, then it's going to just include everything that is not overlapping with the previous object. And so when I started designing this plugin, that was really for that, to do something that would go, a bit faster than what I had before.
Question.
Yes, go ahead.
If I don't have a drawing tablet, what do I use again?
You just use your mouse. It's going to work with your mouse, but it's just going to be more painful to do. But it's it works as well.
But I have to press the wheel, or which button?
Just the left click.
Oh. Okay. In add object. Okay, good. I see. Good. Thanks.
And so you can add your objects like this pretty fastly. But you can do also other actions. So you can remove objects. So when you select remove objects, you just hit the objects you want to remove, and they're gone. You can merge objects. So when you want to merge objects, you select the first object and then its outline, and then you select the second object you want to merge with. And you can go like this. Of course, you cannot merge objects that are not touching. If you try to do so, you're going to have a message that tells you only touching objects can be merged together. If you want to unselect an object, you can just select it again. The next operation you can do is to split objects. So you can try to separate these objects again. And it works fine. The only limitation when you try to split objects is that you need to start outside a nucleus, so like here, for example, and going outside again, so it can be split. And sometimes it's not possible or difficult. Let's say you want to split this object into two. You can start from here, but then you arrive in another nucleus, and that won't work because when you try to split a nucleus, it has to cross entirely only one nucleus. So that's the limitation of it. And now the last thing you can do is to swap class. So this needs a little bit more of explanation. Here for now, we only have one class of nuclei. And for this class, you can actually change the color. So here it's in red. You can change it to, let's say, magenta, for example. So it depends what this is just for visualization. You can add a new class by hitting add new class. And this can be useful if you try to identify different kinds of objects that you want later on to be able to identify. So let's say, for example, in that case, I want to be able to automatically segment stromal nuclei and epithelial nuclei. In that case, you would have one class for your stromal nuclei and one class for your epithelial nuclei. And then you can feed a classifier to try not only to segment nuclei, but to segment specific nuclei. In our case, that's not, so that can be useful. The way I do it, I don't think that is that much useful because I'd rather segment nuclei and then segment the epithelium and segment the stroma, and then I have the same information. But that could be, something you want to do, and for many of the applications that might be useful. So that's why you can have several classes. Now, when you add a new class, you can define nuclei in your new class.
Is there a limit of classes?
I think it's 5. There's a limit. I think I put it to 5. Not sure, but I think it's 5. 5 or 7. or maybe 10. At the beginning it was 10. I don't remember. But yeah, there's a minimum. We can see it. You know, 5.
And what if we have more classes?
Oh, that's, you know, if it's really useful, that's something that would be pretty easy to change. I didn't put more than 5 classes in your new class, but if you made a mistake and you want to change them in the previous class, okay, yeah, it's still working. It tells me that my connection is not great, but hope it's gonna work. So for example, I realized that, oh no, this nuclei should be in the first class, then I can just change a class into the new class. So it's class 1. I go to swap class, and then I can swap this nuclei in the first class. And I should have let 1 at least. So if I want to put like this and I want to remove them, I can remove the entire class like this. And I can remove the ones I added for nothing. All right. So let's now open a segmentation. So before doing that, I'm gonna can I just get rid of this? No. All right. So I'm gonna just open it to show you what it looks like. So if you go to segmentation, so that's the segmentation. So that's similar to what I showed you before, except that as you have many nuclei, you don't see, but each nucleus has a different intensity. So you can load it here in the object classes. You just hit load. You select the corresponding segmentation, and that's what you have. So I'm going to change it back to red. So as you can see, it's not perfect. So especially, yeah, here it's not perfect. So that's a segmentation I got with a unit with only 3 images in training data set. So that's why it's not perfect, but that's, you know, that serves the purpose here, because I want to show you how you can, you know, correct and improve to then further feed your training data set. So here there's nothing really much different from what I showed you before. It's just that when you have a segmentation like this, you can so you can just get rid of the things that don't correspond to nuclei. And in the exact same way than before, you can annotate your nuclei like this. So let's say that this is obviously wrong. So you can remove everything and then add it again. Yeah, here it's not the best one. Clearly. This is routine. This is clearly wrong. And so then you can just keep going like this. So this is probably, but again, you know, this is hard. So even by eye, it's hard. And so you can improve like this. So here you see that by using an existing segmentation, you're going to save time, even though you might have regions. Basically here, it works well in the stroma. And in the epithelium, not that well. And when you have really tightly packed region like this, not great. But that's going to be already a little faster than just doing everything again. So now you can just load the segmentation, play a little bit with it, and just see how it responds. Obviously, you're not going to spend a lot of time. Your goal here is not to segment my image. So let's just you know, play with it a little bit, and then we'll look at the regions. All right. So if there's no other question, we're gonna switch to the region annotation now. So let me just do that. Okay. So something in the visualization that we couldn't test before, you can hide your objects or put them back. Okay. So now we're gonna just annotate the epithelium. So in that case, we don't want to have the object because it's not very convenient. So I'm going to just hide them, and I'm going to select DAPI and cytokeratin. And then, so in a very similar way than object annotation, you have region annotation. So if you hit Add Area, now you can just add your different regions. So, you do the same thing. And same thing, you can change the color. Say we put it in cyan. And you can remove, you can add different classes. So let me just keep going like this. Say, I want to annotate this as another. So if you go, outside, you just take everything that is inside this. And then, for example, here I want to have, so epithelium, stroma, and also background, because here, there's something, everything, but sometimes you also have a part of your image that is outside the tissue. And another question too is that you have the lumen, and is your lumen part of the epithelium or part of the background? It's up to you, but if you want to use a classifier to directly recognize epithelium, stroma, and background, it's going to be much more powerful if your lumen is part of the background because they have very similar features. And lumen can be very large. So even though the lumen is always surrounded by epithelium, it might be hard for your classifier to differentiate between lumen and background. So let's say, so here we have class 1 for epithelium. Same way we can add a new class. And this class is going to be background and lumen, for example. So here it's a bit tricky because you see you have these different things. So I'm going to go a bit fast. It's not going to be perfect. Should be fine still. Okay, let's say, okay, I'm going to go like this. And here I did it that way because it's very important to do the lumen first and then the epithelium, because when you annotate, you cannot annotate a region and then try to do a hole in it. That won't work. So you need to start by the inside and then go for the outside. The good thing is that now you can go faster if you go back to your epithelium. Now, so you can go a bit. I'm going a bit fast, but let's say it's fine. So you just outline your epithelium. And so that's not what I wanted to do, but you see, went back to the beginning, and then I can just finish like that. And as for objects in region, you cannot have a pixel that belongs to 2 different regions. So that's why if I go outside now, as this region were defined as class 2, everything else is defined as class 1. And of course, here we would have a different class, which is the stroma. So let me define it for this region. And now I can go very fast because, again, a pixel cannot belong to 2 classes at once. And now I have all this other region that is part of the stroma. So if we don't have any question, we're going to see now how we can load the regions. So let me just show you what it looks like. So if you go in the regions folder, this is what it looks like. So here I just defined two classes. I didn't define the background. So for this image, it doesn't matter because there's no background. But you could do that also. You just define two classes, and everything that is not in your two classes is going to define a third class. It would be another way to do it. And here I didn't differentiate the lumen from the background. So the epithelium includes the lumen, and that's in that case, you have a stack for each class. So that's the epithelium, and that's the stroma. And so if I load it here, so this is what I get. So here you see, can change, maybe this is not great. Let's put it in green, for example. So, no, that's not this one. Yeah. So here the epithelium is in red, the stroma is in green, and we can add a nuclei on top of that. So maybe, so when you, so let's say this is final, it's definitely not final, but you're happy with your segmentation. When you have all your colors, I'd suggest to use a gray so you can, so with a region, it's not that great, but you can better visualize. When it's in red, it's a bit too busy, I'd say. So here we have all of it. So we could have, let's say, so that's what Mike suggested before. If you want to do your region automatically, yes, in that case, if I just threshold, so if I do stack to images and I just threshold this, that would be a way to do it. Let me just filter it a little bit. So let's do a Gaussian blur. And let's do a thresholding. So here it works in some way, except that you have to fill in the holes. So let's do something like this. And then fill holes. You see, it's not that bad. And then you could load this as a region. So here in that case, of course, the lumen is not part of the epithelium because there's no cytokeratin in the lumen as well. But you see, that would be a way to do your to segment your region. So in that case, training a deep learning classifier might not be useful. You could just do a thresholding. At the same time, I would say that annotating regions is really fast, and so it takes about, let's say, 15 minutes per image. You spend half a day annotating regions, and then you use a deep learning classifier, and it's going to work extremely well. So that's another way to look at it. Anyway, so now we have regions, we have nuclei. What can we do from there? We can do snapshots. So let's say you want to add a figure in a manuscript or for a presentation, and you just want to show how well you can segment nuclei, which is here not that that great, but let's say that you want to show that. You can use the snapshot here, and you get your nuclei that are overlaid on top of your image. If you want to have the regions as well, you do your snapshot, and that's the same thing. Or you can just do your region, and that works too. And so you see here, the snapshot is just an RGB image. So you can save it as a PNG or even JPEG and include it in your presentation, for example. You can also already do an analysis, and that's where we use the ROI the same way you would use it with Fiji. So first of all, so it's better to start by defining the features you want to extract. So if you go to Analyze and Set Measurements, that's where you're gonna choose which features you want. So let's say this is fine. You have the area, you have the mean intensity for each channel and the centroid, so the coordinates of the centroids. Let's say I'm fine with that. Then you can just hit measurements, and as you can see, it just opens the ride manager, do the measurements for each ride, and that's it. So as you can see, it's not what I want you to do. Okay. All right, that's okay. So you have for each row correspond to a different nucleus. You have the area. You have the mean intensity for channel 1, 2, 3, 4, 5, 6, and 7, and the coordinates here, and also the region class. So we have two regions. The one is the epithelium, and the 2 is the stroma. So you know that this nucleus is part of the epithelium. This one is part of the stroma. And so you can save your file, you can open it with your Excel, etc. And here you have, you see, 2,600 nuclei in that case. At the beginning, so now we're going to look at the marker annotation. At the beginning, I wasn't thinking about doing any marker annotation because there are other tools to do that. But then I had this tool and I said, okay, it's not going to be a lot of development, additional development, and that can be useful. So that's why I added this marker annotation. So let's go back to the plugin. So as I said before, so we've been using the object annotation tool for now so far. Now we're going to go to the marker annotation. And in that case, so we still have the regions and the objects. When you look at the marker annotation, what you're going to do is trying to associate markers, so the other channels, to the objects you defined, which here are nuclei. So you can already look at it now that we have the segmentation. Again, not that perfect, but you can look at your different channel and see if you have, positive nuclei. So for example, this is Tibet, and you see there are not that many nuclei that are Tibet positive, but clearly here you have one, here you have one, probably here you have one. So this is a nuclear marker. Oh, that's something I forgot. We're going to do that now. So this Tibet is nuclear. Now, if you go to channel 3, which is CD8, you see it's not a nuclear marker. It's a nuclear membrane marker. It's positive on the membrane. And if we go to cytokeratin, this is a cytoplasmic marker. So you see the inside, when it's really clean like this, the inside of the nucleus is dark, but the outside of the nucleus is not. So here it's important to be able to look at these different regions, the nucleus, the nuclear membrane, and the cytoplasm. So so ideally, you would have a marker for the membrane and a marker for the cytoplasm. And it would be very helpful to segment the nuclei as well. But when you do that, your panel is not as large. And so generally people don't use these markers because they want to have more information about the kind of cells they have. But we can somehow do it computationally. So for the nuclear marker, it's easy. We look at the inner part of the nuclei. For the nuclear membrane, we look at a small region that is defined a little bit inside the nucleus and a little bit outside the nucleus. And for cytoplasmic region, we look a little bit at the membrane, but mainly outside of the nucleus. Now, if we want to do that, the plugin uses actually another plugin. So you need to install another plugin. So we're going to do that right now. So as you remember, you can do it here if you just go to help and then update. That's how we install Annotator. So here we're going to install another plugin. It's the 3D Suite. So maybe you already have it. If you don't have it, you just go as before, manage update sites, and you check 3D image chase through it. It's a plugin that is extremely fast to do so morphological operation like erosion and dilations. But when you have lots of labels, which is what we have here, we have nucleus. We want to do this kind of operation, but for each individual nucleus, and they already have something really powerful. So that's why we use that. So you add it, you close it, and now it's going to install the required plugins. So I just apply changes, and I'm going to have to restart ImageJ. So if you have any trouble with that, just tell me. Let's close that. So I'm going to restart ImageJ. All right. And now if you go to plugin, you see you have a 3D suite. So let's open again Annotator. All right. And we're going to open same image as before. We're going to load the segmentation. So if you have very large image, segmentation might take a little bit more time, but you can always look at the progress bar here. It tells you how long it's going to take. Let's load the region as well. So regions, it's much faster. All right, and let's go back to the marker annotation. I'm going to take my drawing tablet again. All right. So now let's say that you want to identify markers. There are 3 ways to do it. There's a manual way, a segmentation way, thresholding, and a logistic regression. So I'm going to show you quickly how it works when you do it manually. So when you add a new marker, as you can see, you can choose between nuclear membrane and cytoplasmic. So we're going to just use the nuclear and the manual annotation. Can also do the thresholding and the machine learning, which is the logistic regression. Just do a manual annotation. If you want to do it manually, let's say I want to, so I'm going to hide the regions. I'm going to look at the Tibet. And here you see it's, if you don't have many images, it's what? Yeah, I think there was a memory issue here, but anyway, so you can, just select the ones that are positive, and you're good. So it's fast to do it manually because you just need to click to select the nuclei. But if you have many images, you don't want to do that. If you look at the panel, so the same way you can load or save. So we'll see what it looks like later. You can add new markers. So generally, you want to do it for each of your channel, except for the DAPI, because it doesn't correspond to a marker. You can, again, change the color. So you could use the same color because the positive markers, they have a larger, let me show you, if we zoom in, it's going to be more striking. You see it's larger, but it's easier if you have a different color, of course. And now, as you can see, we have different patterns. I'm not gonna spend time on this because it was for a previous application. It's not really useful for this kind of images. It was just to be able for a given marker to have different patterns. It was so in the particular application we were using PHP and PHP and EDU. PHP can be diffuse and punctate, so we wanted to have different patterns. Anyway, that doesn't really matter. So here we're just going to use the P1, and that's fine. So that's how you do it manually. You can remove your markers as well. So let's just remove it. And now I'm going to show you how you can use the thresholding tool, which makes more sense, I would say. So let's say I want to add a new marker. It's a nuclear marker. It's the Tibet. Okay. And I'm going to use the thresholding tool. Okay. This corresponds to channel 2. So I'm going to check channel 2. Okay. And now you have a new window that pops up, which gonna allows you to do your thresholding. So as you can see, there are two different thresholds. There's a threshold on the intensity and a threshold on the region. So what does that mean? In that case, it means that all the nuclei that have at least 35% of the pixels that have an intensity threshold above 1111 are positive. So if you decrease the intensity, so here it might not be the best example because we have very few, we don't have a lot of signal, but it's the thresholding tool of Fiji. So the pixels that are above the threshold appear are green, while the other ones just show their intensity, their real intensity. And you see, if I decrease it low enough, then this nucleus is also positive. If I go very, very low, now you see you have pixels that are in the background corresponding to noise, but are above the threshold. And if I go really, really low, I'm probably going to have, you know, I have one nucleus. Sorry. Can't. One nucleus that is positive that shouldn't, but clearly you don't want to do that. So you can play with the region thresholding. For example, here, you know, if we have this, if I decrease the region thresholding, I'm going to get also this other nucleus as positive, because when I have like, I guess 10%, yeah, now it's positive. I would say, you know, if your intensity is pretty, if your marker is pretty clean, 35%, at least for nuclear markers, is generally pretty good. So you can set the threshold also manually like this. And so generally, at least in my experience, generally what I do is I don't touch this one, and I play with that. And I think this one is positive, so I would go low enough to get it. But for you know, for certain situation, playing with this threshold can be useful as well. And when you're down, no, just hit OK. And now, so it's a bit, you know, it's a bit hard to visualize when you have everything like this. But if you just look at your channel of interest, now you see all the nuclei are in red. The negative nuclei are in red, and the positive are in magenta. And you can see which nuclei are positive. So then I'm going to show you how you can use the logistic regression. So it works. So it's still the same pattern. You first add new marker, and then you choose the type of marker. So we're going to do CD8, so that's a nuclear membrane marker. And here I'm going to use the machine learning, okay? And I need to define which channel is associated with this marker. In that case, so it's CD8, it's channel 3. And then, so it's easier if you just visualize your channel of interest. And so the way it works is that you need to label positive nuclei. So that's what the N plus is. So again, you click on the nuclei that are positive. So you don't have to define all of them, but ideally you define nuclei that are representative of what you do, so what you have. So positive nuclei, negative nuclei. And if you have some that are like borderline, where you have, so for example, this should be negative because you have some fluorescence just on the border. It's probably because of the segmentation that is not great as well. So you define negative nuclei, and then you train your classifier. And so here it takes time because it needs to extract the nuclear membrane, but when it's done, you can do it again, and it's going to be fast now. So then you can update. For example, this should be negative, so I'm going to change the label. And this, I think, should be negative as well. Do we miss some? I don't think so. So then I can train it again, and you see it updates your results. So something you need to know is that this classifier takes into account 4 features: the average intensity and the standard deviation of the intensity in the area. So here it's nuclear membrane, so it's in the nuclear membrane area. If it were a nuclear marker, it would look at this, so average intensity or standard deviation intensity inside the nucleus. Same thing for cytoplasm. It also takes into account the size of the nucleus, and finally the shape, so the ellipticity, so depending if it's round or elongated. So that's great. You can have all the features because for example, you have some if you were to identify endothelial cells, they are very elongated, so taking into account the ellipticity is also of interest. The thing is that sometimes you might see weird behavior, like you train your classifier, it's fine, you add a few of the nuclei, and suddenly you have lots of positive nuclei, and if you look at them, they're all big or they're all small. And it might be because you selected, for your positive nuclei, you only selected large nuclei, while you also have small nuclei, but you didn't do it on purpose, but you only select large nuclei, and at the end, all the large nuclei are considered as positive. So in that case, it's no big deal. You just need to identify also negative nuclei that would be large, for example, or positive nuclei that would be small. And same thing with this shape. So generally, it works fine, but sometimes you just have weird behavior. It's just because the classifier cannot converge with the features it has, and you just need to add other features. So that's how it works. Now, something I would advise is to not to do it on one image, but to do it on several images. And you can do it by selecting here load image and segmentation. So if you hit load, then now you can select a couple of new images where you have the image and object segmentation. So let's select the second image and the corresponding segmentation. And now, so you open the same thing, but you can, so you see, it takes some time because it just needs to redo everything, but I think now should be good. And if you look at your image, so the thresholding has been applied, and you see, seems to work fine. Maybe we missed some, so maybe we should change the threshold. If you go to your marker tool, that's the ones that are selected. And as you can see on this image, we are missing quite some. So we need to add. So the classifier is still there. And now we're just going to add new label nuclei because I know that these guys should be positive, right? Okay. So you can train again, and now it looks better. And so ideally, you do it for a few images. I would say 5 is minimum. I would say if you want to make sure, you can even, you don't have to. If the classifier behaves quite well, you don't have to add new labels because they're good, but it might be a good idea to check that it's working well on several images just to make sure that your classifier is well trained and that you obtain something that is satisfying. So, for example, here, it's still not sensitive enough. Here it looks pretty good. So so you see here, so we had the first part for the annotation, manual annotation, so that's good. Ideally in your project, you're gonna start by using that to build your training data set. Then you can segment your nuclei. You might be able to segment also the regions. And then when you have all these images, you can go to the marker. So you're gonna use, so I would suggest to use more the logistic regression, the machine learning approach than the thresholding. But if you like the thresholding and you don't have variations across your images, you can also use the thresholding. And you can do it. So if you use the thresholding, you can do it on one image. If you use the classifiers, I would suggest to do it on several images. But you don't want to do it for each individual image, especially if you have whole slide images. You might have 100 tiles or even more per slide, and you might have several slides. So you're not going to do it for each individual image. You want to do it in a batch processing way. And that's where you can use the batch. So maybe I forgot to, so maybe before going to the batch, just to show you what you can do for an individual image, measurement and snapshot. So similarly to the previous, to the object annotation, if you do a snapshot, now it's going to be for your markers. And that's what it looks like. It's going to save your different markers. So here we have 3 different markers, Tibet, CD8, and cytokeratin. And so here your first channel corresponds to Tibet. It's a nuclear marker, so you can see it's red inside the nuclei that are positive. The second channel is going to be your CD8. So it's in green, and it's nuclear membrane. So you see it's at this region for your nuclei. And finally, you have the cytokeratin, the third channel, that shows you the cytoplasmic region for the nuclei that were considered as positive. You can also do a measurement. And so here it's going to be similar to what we had before, except that you have the marker information. So let's just give it the time, because now it also look at the nuclear component, the cytoplasmic component, and the nuclear membrane. So for the measurements we had, so we still have 1 row per nucleus, and you have the area for each nucleus. You have the average intensity in the nuclear component for each individual channel. Then you're going to have the nuclear membrane intensity for each channel. You're going to have the cytoplasmic intensity, average intensity for each channel. And finally, you're going to have an intensity for the cell. And still the coordinates for each nucleus. And now you have a label for each marker. So you know that the first marker is positive for marker 3. And if we go down, we're going to see probably nuclei that are positive for other markers. Not that many. So here you have 1 nucleus that is positive for marker 2, which is CD8. And if we look for Tibet, there are only 3 in the image. So I saw 1. Here you have 1 nucleus that is positive for Tibet. So that works like before. Now let's see how we can batch process. So when you're ready, you hit batch. And you're going to go through a series of questions. So first of all, it asks you if you want to batch process marker-associated objects. So most of the time, that's exactly what you want to do. So you're going to answer yes. And then it lets you the possibility to either use images where your markers were identified. So I didn't show you, you can save it. We'll see what it looks like because we're going to save it. So you could load images that you saved before to identify markers, or if you were to use a different method with another algorithm outside Annotator, you could use them to identify the markers. Or you can use what we use here, so a thresholding for marker 1 and a logistic regression for marker 2 and 3. So that's what we want. So the previously defined thresholding and or machine learning methods. So I'm going to hit OK. And then it asks you if you want to also have regions, so areas. So here we also have labels for epithelium and stroma. So I'm going to say yes. And do you want to batch process them for visual inspection? So in that case, it's going to generate for each image an output image where you have the input image with the nuclei that are overlaid on top and an image with the markers. So here I would really advise to say yes, because when you batch process, it's always risky to batch process a whole set of images without checking them, because maybe what you did makes sense for the images you were working with, but it's not going to work for the other images. And it's always better to make sure that you don't have outliers in your input images. And if you don't check them, you won't know. Because here you see we have lots of features. We have measurements, so we have lots and lots of features. And you will always have numbers to process, to analyze. But if these numbers don't really correspond to something that's happening in your images, that's not good. So I would also very much suggest to hit yes. And now you have this window where you're going to define where your input images are and when your output going to be. So first thing is input images. So that's your the images you open where you have all your channels. So if you hit image folder, then here it corresponds to the images folder. So I'm going to select the images, go inside the images folder and select it. Then it asks you for the segmentation. The segmentation are in the segmentation folder. So I got to select this. And then it asks for the areas. So we have the regions folder where we have the stroma and the epithelium that are annotated. So I'm going to select it. Now you have the next one is where you want to save the images corresponding to the markers that will be identified. So I'm going to create a folder that I'm going to call marker associated nuclei, for example. All right, I'm going to select this folder. Then it asks you for the measurement, the results. So I'm going to define a new folder. I'm going to call results and select it. All right. And finally, so the result images, so for visual inspection, so I'm going to create a new folder again. That I'm going to call result images, for example. Now that all of this is defined, so your input and your output are defined, there are going to be two more steps. The first one is if you have markers that don't overlap. So here in that case, we have, I'm going to take my notes because I know less about this. So we have CD8, and CD8 only stands for CD8 cytotoxic T cells. We have Tibet, that is a transcription factor, so that can be useful to have also the Tibet, and we have the CD8 Tibet, which corresponds to other cytotoxic T cells. So we know that CD8 and Tibet, marker 1 and marker 2, can overlap. However, cytokeratin cannot coincide with either Tibet or CD8. So what I'm going to do is I'm going to just say that marker 3, cytokeratin, cannot coincide with Tibet and CD8, and that will prevent you to have nuclei that are that have a label that that you know is not possible. And so I'm just going to hit OK now. And the last thing you can do is to add combination of markers, and that's pretty convenient, especially for the post-processing. So I'm going to show you what it looks like, and then you'll see how it can be useful. So it asks you if you want to add a combination of markers. So here, the markers we have are Tibet, CD8, and cytokeratin. And I know that I have also CD8 and Tibet together that corresponds to markers. So I'm going to have 4 different combination of markers, even some combination are unique markers. I'm going to say yes. The first one I'm going to define is Tibet. So I give a name. I said, OK, and this is marker 1. I want to add another one, which is CD8. Okay, and that's marker 2. So take your time here because it's important to not to rush. Then I want to add CD8 Tibet because I know that this is another possibility. So I hit OK, and I know it's marker 1 and marker 2. Okay, so I select both markers and I say OK. And finally, I'm going to add cytokeratin, which is marker 3. And now I'm good, so I won't add any other combination. I say no. And now it starts to batch process your results. So it opens everything. And then it opens the image, it opens the segmentation. It is pretty fast. Then it applies the classifiers, and it can take some time, especially here we have nuclear membrane areas and cytoplasmic areas to define. So that's going to take a bit of time. And then it goes through the measurements. So here the measurement is going to take quite some time because we have the intensity. If you're not interested in the intensity in the set measurements, I would suggest not to add them because that's what's going to take most time. So here I put them, so it's going to take more time. So it's going to let us time to talk about, to ask questions and everything. But yeah, the time it takes to go through all the nuclei and measuring for each channel, that's what's going to take time here. While it's running, it should be down soon, but I'm going to just go back here and show you one thing. Just hope I won't interfere with ImageJ. So there's a GitHub page for Annotator. Where you have all the code. So if some of you are interested in getting the code, changing it or anything, so you can do it, obviously. You also have video tutorials here. So if you want to go back to some steps, you can access these video tutorials and look at them. This tutorial is also recorded, so you'll have access to it. I don't know when. I guess pretty soon. The organizers will send a message to everyone. But I just wanted to mention that other tutorials are there, and the code is there. I'm gonna check where it is. So we're up to the last image. So maybe one thing I can show you quickly, and we'll get back to it because I know that some of you are interested. Phenopter. This Phenopter is it there? It's an R package. So that's the example, I don't know. So that's an R package that's been developed by people that work at Akoya. So Akoya is a company that does the vector polarize, that does other, I don't remember how it's called, where you can have many other markers. And so they developed this R package that allows you to do quite some analysis. So I think we're done now. No, not yet. So I just wanted, there's another page. Tutorials. I guess that's this one. Yeah. So we'll go back to it right after it. Now it's done. So I'm going to show you the results you get. So let's open the folder. And so everything is in there. So images, regions, and segmentation were already defined, so they haven't changed. Now, so one thing I didn't mention, something that is important, the names of the images, so for regions and segmentations, have to be the same than the name in the images. That's how the plugin knows that it's batch processing. So you need to have, so if you go there, you see you have the name, it's the exact same name in segmentation, and it's the exact same name in the regions. So let's have a look at what was generated. First of all, the result images. So that's where you can have the visual inspection of your results. So if you open it, you see you have, so that's the first image. You have your input image with so the nuclei that are overlaid in red here, and the regions. If you don't want to have these colors, you need to, before doing your batch processing, you need to define the right colors. So here, for example, if you were to have defined gray for your nuclei, I would have this instead of this. So the colors here depends on how they were defined here. But that's very important because here, as you can see, you can look at your results. And let me show you, that's the, is it working? I don't know where I am. So I'm, okay, so that's, yeah, okay. And that's the results for your markers. So here you have your region, you can see you have your region, so dark red corresponding to the epithelium and dark green for your stroma. And then you have your three markers. So in red, Tibet, in green, CD8, and in blue, cytokeratin. So going back to the visual inspection, here we have the markers. So each channel corresponds to a different marker, and we also have the regions. So that's just a way to look at your results. Okay. Now let's look at what was generated as well. We had, the other thing we had is the marker associated nuclei. So that's more if you want to go back to your results. So the format is that for each marker, the positive nuclei are labeled as one. So that's for the first marker, the second, and the third one. So for example, if you would like to go back to your results, you can open Annotator. Oh, I have an image that is open. So I'm gonna close it and I'm gonna open it again. So if you have an image that is opened already, Annotator is gonna open that image. So it's gonna open with that image inside. So let's just go back here and I'm gonna load the segmentation. And now I can load. So if I want to go back to the markers that were identified, I can open the marker associated nuclei corresponding. And now you have your positive marker for Tibet here, and so on for CD8 and for cytokeratin. And finally, the other output is so corresponds to the results. So here you have two files for each image, and so there's one that is about areas. It's because we had regions in our analysis. So if you open it, it's very simple. It just tell you the area you have in region 1 and the area you have in region 2. So it's just if you're interested to know the total area of epithelium, total area of stroma, for example. And you also have, so the kind of file I showed you before when you just do measurement. So here you have one row per nucleus, and you have the area, you have the average intensity in the nuclear component, in the nuclear membrane, in cytoplasm, and in the cell for each channel. And finally, you also have the coordinates. And then you have a label for your regions. So here, 1 corresponds to epithelium and 2 to stroma. and you have a marker for, so a label for your 3 markers. So for example, this cell is positive for marker 3, and that tells you that these nuclei are positive for cytokeratin, but you can also look at other combinations. So here, let's check. So we don't have lots of CD8. I saw one. Well, you get the idea. So you have all your markers that are defined like this, and so you have not only the markers that were identified, but also the combination of markers, which might be very helpful to do the post-processing analysis. So I'm just gonna quickly show you Phenopter because I think it might be interesting. So I'm not gonna show you how to use it. That's an R package, but it's fairly easy to use. And where are the tutorials? They have nice tutorials. Let me check. Yeah. So if you go to the tutorials, you have, so they help you how to use it. And basically, I'm going to show you the format they have. So the thing is that the format of the output file I just show you is user friendly with this. So you can easily use the output from Annotator to plug in directly into Phenopter. And then the good thing is you have many tools you can use. So for example, this is from this file, you can visualize the distribution of intensity. So for example, here it's the PDL1 intensity over your different phenotypes. So that's the different kind of cells you identify. So here it's only single positive nuclei. So they had CD68, CD8, cytokeratin, and FOXP3. You could do it for a combination of markers as well. And you can also do some spatial distribution analysis. So like this one, so that's what I showed you in the PowerPoint, where you look at the distribution, the spatial distribution of your different phenotypes of your different cells. You can also use the same thing to do some nearest neighbor analysis. So if you have to analyze images like this, Phenopter is really a good starting point. They already have lots of tools. It requires a little bit of our understanding, but you don't need to be an expert in R to do it. You can just use the package, go through the tutorials, and you'll be able to already do interesting analysis.